In this unit, we're going to learn how to compare and contrast the linear, quadratic, and exponential functions. So first, in this section, we're going to start by identifying just what each shape makes. Linear functions are straight lines. You can see some examples here. Quadratics make a shape called a parabola, and you can see it either upright or upside down. And exponential functions make this, it has an asymptote with it grows really fast or decays really fast. And so the first thing is, these are some example scatter plots where some people just plotted some points on some graph paper, and they're looking for, if they had to pick a model, what would be the best model that might kind of describe the shape or general shape it's making. And I can kind of see this one's kind of making like a U shape that looks kind of comparable to a parabola. It doesn't perfectly fit every point, but it makes a general parabola shape, so that would be a quadratic function. And the next one, you can kind of see it looks like it levels off and then takes off really fast, so it looks like exponential growth because from left to right it goes up. And then the next one makes an upside down kind of U or parabola shape. So that would be again a quadratic with a maximum. And the next one's fairly linear. It kind of goes just straight in one direction. It rises and runs together, so that'd probably be linear. And this last one looks like it's an exponential decay. From left to right it goes down. It kind of levels off on the x-axis. Alright, so see if you can do this next set of matching based on what we've just learned already, and pause the video. If you've unpaused the video, okay, let's go through each one of these. It says an exponential function that is always increasing. Alright, so first of all, we've got to identify the fact that the exponential functions are probably c and f. And the idea is, let's just rewrite these. So first we have a quadratic for a. Let me put down what each of these functions are first. So a quadratic for a. It's a linear for b. C is exponential. D is also linear. E is quadratic. It makes a parabola. And finally, the last one is also exponential because it has an asymptote and grows. So let me just write exp for that. Alright, so I'm looking for which one of these three functions for the first one is always increasing. That means as I move left to right, it's going up. So as I start at the left-hand side of this one, it's going down, so that's not exponential growth. As I start at the left-hand side for this one, it goes up, that's exponential growth. So this one's f. So we use that one now. Alright, the next one, exponential function that is always decreasing. Alright, you can see there's only one other exponential function, and from left to right it gets smaller and smaller and smaller. It looks like it levels out, but it does continually get closer and closer to its asymptote, so it's always decreasing, even if it decreases slower and slower and slower. C is always decreasing. Alright, the next, a quadratic with a local maximum. Alright, so we have two quadratics. If it has the top of a hill, like that's the very top of a hill, that would be considered a maximum right there. The top of the hill is a max. And when it bottoms out like in a valley, that would be considered a min, or a local min right there. So if I want a quadratic function with a local maximum, it would be e. And if I want a quadratic with a local minimum, we talked about that, where it bottoms out, that would be a. And finally, next, a linear function that is always increasing. So which line is going up from left to right? This one from left to right is going uphill, so it looks like b. And this one's going downhill, so b is a linear function that is always going up. The last one, a linear function that is always decreasing. If you look at this one, it's from left to right, it's going down. So that would be d. Alright, I'll stop here and I'll start the next video in just a moment.